Today we're going to be talking about Bose headphones, and you've probably seen people on airplanes wearing these and wonder why they're wearing these big headphones on airplanes. We're going to talk about what they are and what they do coming up. My name's Todd, and on this channel we try to give helpful information to developing musicians, to people who are curious about music and how sound works, and also just curious onlookers who are interested in what music does and how it operates. So we're doing another session today talking about some fundamental ideas around the subject of acoustics. Now recently it was brought up to me, somebody saw somebody on a plane wearing these Bose acoustic headphones. And Bose is a music company that has been around a long time, and they produce high quality audio gear. And so they've produced these headphones, and they're called noise canceling headphones. Now they do two things extremely well. The first is that they are high quality headphones that create really great sounding music. But the second thing, and that's the subject of this video today, is that they do another thing which is pretty cool. It's almost magical, and it's called noise canceling. And basically if you put these headphones on, it's going to cancel out all the sound that's outside of the headphones that you're wearing. So if you're walking outside and you hear some music going on and it's playing whatever, and all of a sudden, that's right, everything becomes completely silent. And again, that's the application I think many people have enjoyed about them on a plane. There's many people who are a little bit intolerant of kids yelling on planes or whatever, even just the noise of the airplane itself. And they'll wear these headphones so that they'll cut out all that outside noise, make it very silent, and they can listen to their own music at the same time. So exactly how does this work, this canceling of noise? This is a technology that is called phase cancellation. Again, they call theirs noise cancellation, but fundamentally it's something called phase cancellation. Now in the early years of sound engineering and sound recording, back in the 40s and 50s, primarily in the 50s, there wasn't really great power grids or electrical grounding that would happen in certain buildings, and so there might be something like a symphony, a national symphony, who's going to do their big recording of a symphony, Beethoven's Ninth Symphony. And they would go into this old, beautiful hall, which acoustically sounds great, but the electrical grid inside the building may not have been very good. And so the net result would be the symphony would make their performance, the sound engineering team would be there, they'd be plugged into the power in the building, they'd have mics that were hanging over the orchestra, they'd capture the performance very well. Then they'd take the recording, they'd go back to the studio to mix it and get it cleaned up, and they realize that they've got a buzz on there. And most often in those instances there would be something like a light bulb, your standard kind of a light bulb like this one over here, and standard light bulbs happen to create what's called a 60 cycle hum. In other words, the power from the wall generates at 60 hertz. And so 60 hertz, if it's not on a different circuit from the circuit the soundboard is plugged into, that will infect the sound that is picked up here. So an engineer would go back and he'd hear this 60 cycle hum on his recording, and he'd be, oh no, we've got this beautiful recording, and yet we've got this buzz that's ringing through here. So what do? So this is where the magic comes in. I've talked in the past couple of videos about sound waves, and so right here you can see this chart of a sound wave. A sound wave has a positive phase and a negative phase. You see that it goes up and down, and when it goes up and down, that is called 1 cycle or 1 hertz. So the more cycles per second is when you start talking about things like 40 hertz, 550 hertz. 440 hertz is actually the A below middle C. So those are frequencies, and those cycles are made up of lots of sound waves, the repetition of sound waves at different speeds to create those different pitches. So that 60 cycle hum, again at 60 cycles per second, is what would show up there. And so these engineers would use a machine that would go ahead and take that frequency, and then they would change the phase So at the front end where you see the positive phase, they would go ahead and spit into that, the reverse of that. So the negative phase of that would play at the same time the positive phase would happen. And what that does is a physical phenomena, a physics phenomena, and it would cancel that noise altogether. So the engineer would put in that negative phased 60 hertz hum into the recording, and like magic, that buzz would disappear. And that's what noise cancellation does. It'll take the phase of a sound wave and it'll go ahead and invert it so that it goes right against the positive. So you get your positive phase and your negative phase. And so instead of being offset like this, they're at the same time, and it creates a canceling of that sound wave. And that's basically what, when we talk about Bose headphones and noise canceling, what that does. We flash forward now to the current technology, and Bose headphones, what they do is that they have a little microphone on the outside of the earpieces, and they pick up all the sound on the outside of wherever you're at. And then there's circuitry in there that takes that sound and inverts the phase of it, and then it puts that into your earpieces so that it cancels the noise that's outside. Not everything, but it does a massive job of really eliminating your outside sound out there. I used to have a pair of noise canceling earbuds from Bose, and they were awesome. The sound music that they created was terrific, and I would use them when I was mowing the lawn. I'd mow the lawn, and the volume of the lawnmower was almost invisible, but it was really, really great. The music I would listen to would sound good. I didn't have to have them blaring, and it would do what I like to do. I had the idea that I maybe want to use these when we first started to use in-ear monitoring, and an in-ear monitor is what you see now that all major acts use when they're on stage. So instead of having a big speaker cabinet on the ground in front of them playing the sound back to them to listen, you have these in-ear monitors that you put in, and you can hear the mix that the engineer has given to you. Well, I thought these headphones, these Bose noise canceling headphones, would be great. They sound awesome. So I started to use them, and I was in a rehearsal with them, and I didn't think about a very important piece of that. These are noise canceling headphones. So when I went up to the microphone to start singing, I had the hardest time hearing myself, and I kept turning myself up on my little mixer, and I couldn't hear myself in my in-ear monitors as I was singing. And I didn't think about the fact that I have monitors in my ears, and they're listening to the sound of my voice, and they're canceling the sound of the voice and putting them back into my earpieces. So as I block my ears, which is what basically in-ear monitors do, I wasn't getting any vocal sounding in my monitors. So definitely not a good application of using noise cancellation headphones. They're really great for personal use, for canceling noise if you're in a noisy place. So that's basically how Bose headphones works. It listens to the outside world, and it cancels that sound inside of your headphones. Question of the day: what experience have you had with noise canceling or noise canceling headphones? Just go ahead and put that in the comments below here, and we'll see what you have to say about it. Glad you were here today. We're going to be moving away from the acoustics topics for a little while, but we'll be responding to the comments below about the last several topics that we've talked about in this area. I'm glad that you're here today. We'll see you next time.